So here we have an object hanging, one on an inclined plane, and we'll consider friction, kinetic friction of 0.22. And I'm doing something on a worksheet, hence this OSN. We could do like static instead, but go from static to kinetic, but one thing at a time. So here, so, if we did static and kinetic, then it's adding a little more difficulty, trying to go one step at a time, scaffold things up, scaffold like the side of a building when you're building things up. So we did inclined plane, non-inclined plane with friction. So let's go through and do the derivation. Okay, we get our objects like this, M1, M2 connected by a rope. And if I get this and move it across, then M2 down would be like going in a positive direction. I'll call them M1, M2 this time instead of A and B. And different things sometimes. And it's on this worksheet. I'll put a link to, it's M1, M2. So we have M1, M2, M1, M2, and so if we go to the right, as we say, it'll be considered positive, like on the x-axis, left is negative. If it goes right, it's down. Down to the right is going right. Down to the left would be going left. So it matches up nicely. Then if we consider the situation, because we're taking friction into account this time, and friction is always kinetic opposite the direction of motion, static also, but we want to see for our free body diagram, where would we put friction? So if this is 8 kilograms and that's 5, and this is, the parallel is reduced by a factor of sine of 20, you get the normal weight, you get the weight, MA, because remember the parallel force is the weight scaled by the sine of the angle, sine. So this would be our parallel, and so we get 5 times 9.8, reduce it, and so clearly that force is going to be a lot less than this, so we know it's going to be going to the right. If the 8 were here and the 5 were here, then we'd have to look at what the sine of the angle is. It would depend. At some point, if this were 8 and this were 5, we'd be going down the slope this way instead of up the slope. But we think about the problem first, so we know where to put some of our forces and stuff. So here we'll have force of gravity for the second object, tension going this way. And then on this one, tension in the positive direction, parallel going that way, because we got part of gravity parallel to this and part perpendicular. And then we know, based on our thinking in general, our theory, our general context, this is going to be going this way, so friction would be acting this way. So all right, then we can get our equations from this. Remember our MA. So here, tension, so FG2 minus tension, M2A, and here, tension's to the right, these are to the left. So we get that. And then if we solve for t, we can do this, as I say, as a system of equations. Put this one below this one. The t cancels out. You see what's left. Or we could solve for t. Might be clearer if I do it that way. So add t to both sides, subtract this from both sides, do the algebra. You end up with so add t to both sides, it's there, subtract, whoops, it's there, them, so gravity that way, tension, force of gravity, parallel, force of friction. Add these to this side, tension will be F parallel plus F friction plus M1A. Tension's the same in there. So then we got F parallel, force of friction, M1A, force of gravity, M2A. And then we're going to be finding in this number 10 here, acceleration and tension in the string. All right, so we solve for A. So we can do, add this to both sides and subtract these. So this one comes over here. We got this plus this. And these two we subtract, so this minus this minus this. Okay, and of course, that's like the sign for parallel. It's not an 11. You know, we do like M parallel to N in geometry. Two lines are parallel. Then factor out the A and divide. And then on the top, when we put in mass and gravity and angle, it's more complex. So doing it like this at first makes it simpler. So, and if I remember, in an earlier video, I forgot to put in numbers, so I'll try to remember to do this by the formula and then put in numbers. Maybe that kind of makes it easier for you. But, so FG2, simply the weight, it's easy enough. The parallel component, and then the force of friction, kinetic. So we got the parallel force. So parallel is parallel to the plane here. And as we talked about before, the parallel, move it over a little bit. Remember, the component of weight parallel to the inclined plane is the weight times sine of theta. And then the force of friction is the normal component times mu sub k F sub n, which will be mu sub k times mg cosine theta. I'll do it similar to that. All right, so that is going to be plugged in there. And then it's going to be M1 in this case, it's in general. We'll be doing M1. So I shall erase this part and get this and rewrite it up here. Tension, parallel force, there, okay. Then acceleration will equal FG2 M sub 2G minus parallel M1G sine theta minus UK mg cosine theta and one again still, force of friction, one, okay. So parallel and friction are on M1. So M1G sine theta, V sub K M1G cosine theta over M1 plus M2. Then we can factor out the G, and we get M2 minus M1 sine theta minus UK M1 cosine theta over M1 plus M2 times G. So isn't before stuff, it's a fraction of G, or a multiple, whatever the case may be. So then if we work it out, and when I do it, I like do it over with the numbers and stuff. So get rid of this. So M1, M2, that minus that. Make sure I didn't like make a typo or anything, write anything wrong that I catch. I'll see if I made a typographical error or whatever when I get to the answer, and I'll check and see. So now put in numbers. So we got M2 is 8. So the acceleration 8 minus 5 times sine 20 minus 0.22 times 5 cosine 20 then we got 5 plus 8 on the bottom. Then it was 0.22, right? 0.22, yes. Drink of water. Then put it in the calculator. I'll do them separately, top and bottom. So 8 minus, make sure I'm in degree mode. Let's see, mode, degree, good. Start over. 8 minus 5 sine 20, close parenthesis, minus 0.22 times 5 times cosine 20, close parenthesis. So 5.26 on top. And this, I had a typo over 13 divided by 13, about 0.404. And then times G. I was wondering, it seemed weird. 0.404, it can't be. What's going on? What did I forget? Forgot the 9.8. So now times 9.8, 3.96, that sounds better. Meters per second squared. Like an IB speak, that's the -2. So acceleration, positive 3.96. Remember, positive means to the right, means we're going that way, we're going down to the right, as we had thought. It's just scaled because of the angle and stuff and the friction. So now I get the tension, and so 3.96. And so there's a formula you can kind of get familiar with and know, memorize it, you know, or kind of sort of be familiar with it. Know you need like 3 things on top for this situation. And then you can like drive it more quickly and see if you're correct. So now tension, so acceleration, I'll put it over here, 3.96. And this one had a bunch of different stuff. This one would be easier to figure out the tension. All we got is the weight and the tension acting on this one instead of all the stuff on that. That might be more fun, but for the video, I'll just do this one. So we have on this one, free body diagram, remember the weight acting down to the right, goes to the right, up, opposite direction, tension. So the right minus the left is MA. And so move tension over, add it to both sides, subtract this. So that's what the tension would be. So then tension M2G minus M2A, which is G minus A, M2. So the tension would be 9.8 minus 3.96 times 8. And that will be 9.8 minus 3.96. Yeah, I forgot to put parentheses around it. Times 8. 46.72. Newton. And that'd be about 10.5 pounds of force. So that's about 10.5 pounds in English units. All right, acceleration and tension. And then instead of doing a derivation, maybe if you want to put numbers in it first. So if we're trying to get acceleration, let's say, we can calculate some stuff in the first place. So we know still, we got to do our free body diagram and stuff. M1, M2, rope, tension, and then we got force of gravity, tension, parallel component of force, force of friction. And then we can figure these out and put numbers in. Got to do some stuff still, of course. So tension to the right, minus force of friction, minus force parallel, M1A, FG minus tension, M2A, and then solve. We can put numbers in. Solve for T. I'll go ahead and solve for T. T equals, add these to each side, to each side, subtract that. Okay, and so at this point, instead of doing a derivation, we could get these numbers, plug them in, and then go from there. That might be easier. Then you have less derivation stuff. These are each equal to t, so still we know. I'm not gonna write that. We know they'll be equal. So to say, so we get the force of friction. So we're gonna have the force of friction on this. Remember, mu is 0.22. Kinetic. So then we have not working anymore. Force of friction, better, is going to be mu sub k times the normal force, and that's going to be mu sub k times the weight times cosine theta. Okay, from videos before. Then M1 is 5, so we got the force of friction 0.22 times 5 times 9.8 times cosine 20, and we get 0.22 times 5 times 9.8 cosine 20, 10.13. So force of friction (10.13 Newton). So we got that. Now the parallel force, the component of weight, gravity down the inclined plane. Parallel, remember, is going to be the weight cosine theta. So in this case, five times 9.8 times cosine 20, sine 20. As you know, because for one thing, cosine here, sine here. Maybe you can remember for an inclined plane only, not for any situation, but for that, sine is slippery, so sine is down the slope. Cosine is catch. Catch is like friction. Friction catches. So use a mnemonic like that or something, if it helps. So we're going down. Got the 20 there, and then 5 times 9.8 sine 20, 16.76. Okay, and the weight's easy enough. It's just these two involve sine and cosine, the coefficient of friction, so there's something we needed to work out. So we got those numbers. We can go ahead and do that. FG, easy enough, I'll put it in, but this equals this, so force of friction, 10.13 10.13 plus 16.76 plus M1 5.8 equals the weight of this one, of course, 8 times 9.8, 8 times 9.8, 78.4. And so this could be way easier for some people. Instead of doing the formula, solving algebraically, literal equations. We should try to get used to that. An important skill. My computer almost went dark. But sometimes it's just a matter of getting a question right on a test or something. So if this helps, do it. That stuff, the other thing we did, still need to know how to do. Then move this over. So 10.13 plus 16.76 minus 78.4 equals negative 13a. And solve. So 10.13 plus 16.76 minus 78.4. Enter 5151. Divided by negative 13. And again, 3.96. All right. So that might be easier for some people, as I say. Do your free body diagram, get this part, just plug in the numbers and get it. So cool. And then of course we can go on with this stuff and do equations of motion, velocity, distance, time, stuff like that. But you know, one thing at a time. I'll end this video here. It's enough information for now since we included friction this time.